Hi there, then. This is an exercise 4F. We missed out 4E because we did that earlier in the year. So exercise 4F is where we continue our work on geometric sequences. And again, now looking at sums of geometric sequences or series. So a little starter for us. Let's have a look at this. So we've got 4, 6, 9. It does tell me in the question it's a geometric series. So it's not surprising they say to me find the common ratio, and I've already shown you that you find the common ratio by doing the one term divided by any other. So I could do 6 divided by 4, I could do 13.5 divided by 9, as long as you do consecutive terms. And if you do that, you get 1.5. Let's find the 20th term. Now again, what we're after is a reminder of what the 20th term of a geometric sequence is. And its un is AR to the n minus 1. That's the formula that you're meant to be able to use. I think that formula is given to you in the formula book. That's why it's useful to get used to using that form of it, because it's there for you on the day. But anyway, so I want the 20th term. U20 equals A. What was A? A was 4 times by R, which is 1.5 to the power of 19. Because I want to the power of 9. Now it's going to be lots of decimals in my guess, so anyway, but 4 times 1.5 to the power of 19. You don't do 1.5 to the power of 19 without getting a horrible answer, and sure enough it is a horrible answer. 8867.35128, and presumably you'd round that if they asked you to. Part C, the sum of the first 20 terms. Now Part C then is slightly different, as much as I've not really shown you how to do this. This is the purpose of today's lesson. One way of doing it would be to write down all the values. So obviously we've got the first term, which I was going to write U1, but I've just written A instead. 4, then we have 6, then we have 9, then we have 13.5. And I suppose I only want the first 10 terms. You could quite easily keep on timesing these by 1.5 each time, so 13.5 times by 1.5 is 20.25. So that's the first 5 terms done. I need 5 more terms, so I'll just do it 5 more terms. I've got 30.375. Now obviously this is not a very satisfactory method, as much that 45. Well, I nearly made a mistake already. You could quite easily get this wrong, and it's also very slow. Times by 1.5, 68. The good news is there's only 2 more to go after this one. $102.515625. Presumably about 150-ish. 153. Now, I'm going to now spend a couple of minutes typing all those in. So I'm going to pause the video and I'm going to type them in. Okay, so I don't know if you've been typing those in as well with me. When I've typed them in, I got this. S of 10 equals 453, and it actually goes on for quite a number of decimal places. It says 32031255, so presumably I'd round that to 3 significant figures. I'd call it 453, which begs the question why I wrote all those decimals over there, but there you go. So 453-ish is the sum, but there's got to be a better way of doing it than that, and I think you'd agree you would expect there to be. Here's another question, exactly the same. There's 5 terms of geometric sequence. The sum of those is 248. Now on that one I could just type them into my calculator with nice easy numbers. I could do them in my head if I want, but I need something better than that. I need to be able to do this just by using a formula, a bit like we did for arithmetic sequences. And you won't be surprised to learn there is such a formula, and this is it. It's the sum to n terms, and it's a1 minus r to the n over 1 minus r. Sometimes you'll see it written slightly differently. This isn't the formula, but the formula can also be written as this, and you sometimes see it written as r to the n minus 1 over r minus 1. effectively you've times this bracket by -1, you've times the bottom by -1, and that allows you just, it made no difference to it. Now, to be honest, in the old days when you didn't have very good calculators, I would recommend using one or the other, depending on which situation you have. Calculators are so good now, I personally would just learn this formula and just be done with it. I don't think you need now the extra formula. So we're going to use that formula, which I've got down here. Of course, we're going to use our nth term formula as well, and we've got these two formulas we're going to use to work out a variety of things. So first example, calculate the sum of the first 12 terms. Well, it's a sum question, straightforward sum question. The sum of the first 12 terms I'm after. And what have I got? My A is 6, and my R, which I haven't yet got, is 12 divided by 6. And 12 divided by 6 is obviously 2, so it's a nice number. So my sum to n terms using this formula is A 1 minus R, which is 2 to the power of n. Notice I don't take away 1. A lot of the other formulas I have to take away 1, but on this one I don't. You might be wondering where these formulae all come from, and when we get back into college, I will show you proofs for these, and they're relatively straightforward. But then, it's something you might want to look up online, for instance, as well. Anyway, so if I was to type that into my calculator, you might use that as a bracket in there if you've got a decent fraction button on your calculator, which I'm sure you have. Perhaps you don't need it. So I'm going to do with a fraction button 6 times by the bracket 1 minus 2 to the power of 12, close the bracket, divided by 1 minus 2. And it comes up with the answer straight away. I mean, these calculators are very good now. You don't have to worry about them. 24570. So what's the answer say? There you go, 24570. Find the sum of the 15 terms of this GP. So I've got 4 minus 2, 1. So I suppose I need, it doesn't want 3 sig figs here as well. So I need my A is 4. I need my common ratio, and that's take any term divided by the one before it. If you do, you get minus a half. And I want the sum to 15 terms. So the sum to 15 terms is, using this formula down here again, 4 lots of 1 minus r to the n. What's r to the n? That's minus a half to the power of 15. That's where you need your calculator. Divided by 1 minus r, which is 1 minus a minus a half. Obviously it's 1 plus, really. So I'm going to type that into my calculator. Again, using the fraction button. 4 times by the bracket of 1 minus, in a bracket, minus a half. Make sure you use the right negative on that one. To the power of, what was it, power of 15. There's enough places to go wrong in this when you're typing it in, so it wouldn't surprise me at all if people get this wrong when they type it in. I get 2.67 to 366, it's actually 2.6667. I shall round it to 2.67 to 366. Let's see what it actually says. Yeah, good. So I typed it in right, but I wouldn't be surprised if some of you didn't. So let's have a look at the next question. Oops. Yeah. So the sum of the first 6 terms of a GP is 9 times the sum of the first 3 terms. So let's have a look at this one. Make sure that's working again. The sum of the first 6 terms. So the sum to the first 6 terms is 9 times the sum of the first 3 terms. That's what it says. Now, using this formula, I should be able to put that in. It wants a common ratio out of this. So A 1 minus r to the 6 over 1 minus r is 9 times A, and again I'm going to use the 1 minus r to the 3 over 1 minus r. And this is quite nice actually, because a lot of this stuff cancels. That disappears with that, and that disappears with that. And what I'm actually left with is 1 minus r to the 6 on this side is 9, and I'm going to multiply that out, minus 9r cubed. I'm going to get everything on that side, so that will give me r to the 6 minus 9r cubed. If I move that 1 over, it becomes a minus, plus 8 equals near 0. And this is actually a disguised quadratic. Who would have thought we'd get a disguised quadratic out of this? So this is definitely a step up. I don't think necessarily you'll get this on your examples in a bit, but who knows? Maybe it could be a more varied ones if you go to near the end of the exercises. So r to the 6 minus 9r cubed plus 8. So I reckon this is a disguised quadratic. I'm going to effectively r cubed is going to be my x, if you like. So and it would make it like x squared minus 9x plus 8 equals 0. So let's go into this menu and go to A, polynomial of degree 2, and I've got 1 for the first one, I've got negative 9, and then I've got 8. And it won't surprise you that we could have factorised this quite happily. It's x equals the 8, or x equals the 1. Or if you put it another way, r cubed equals 8, or r cubed equals 1. Now, if this one's a bit dodgy actually, this solution, because effectively all the terms would be exactly the same. So I'm going to put this one in brackets, because I don't think, because this gives me r equals 1, I don't think that means anything would ever happen. So presumably this is the one they're after. R cubed is 8, r equals 2. That, I think, is the answer. Yes, it is. This is the last question we're going to look at. It's a pretty simple question. This came on an old Core 2 exam paper, which I've just found an example of. So if we just have a look, the geometric progression. There was actually question 1 on the paper, so I suppose it's a warm-up question. A geometric progression is first term a equals 3, and second term is minus 6. All right, so this is what they asked me to do on the first one. R equals, you always do the one term divided by the term before it, so minus 6 divided by 3 equals minus 2. Got a mark already. Find the value of the 11th term. Okay, it says it's geometric, so I can use this formula. U11 equals A times R, put it in the bracket, to the power of, well, this is the one where we do have to take away 1, to the power of 10. Just do that now, menu back to 1. 3 times, in brackets, negative 2 to the power of 10. 3072. And the last one, the sum of the first 20 terms. So the sum of the first 20 terms, obviously we're using this formula here. A was 3. 1 minus r, what was that? That's minus 2 in the bracket to the power of 20, close bracket, over 1 minus a minus 2. The minuses are probably the easiest place to go wrong in this. But using the fraction button, it's 3 times by the bracket of 1 minus bracket, negative 2 to the power of 20, close the bracket, divided by 1 minus a minus 2. And you could just write 3 there if you want, or type it in properly. And I get a rather large but negative answer. And I'm not surprised it's negative, because it's you can go from plus to minus each term, I think, each times by minus 2. But this particular one, it ends up being minus 104.8575. According to me, anyway. I haven't got the answers. So if I've done it wrong, let me know. Other than that, then I want you to have a look at exercise 4F. This is on Moodle. And again, we take this further in the next exercise. There are things called sums to infinity that we're going to look at on the next exercise for G. But up until then, just have a practice at these and treat them as nice little simultaneous equations questions again sometimes. So all the best.